So today we're going to talk about multi-view drawings, and that's really just different ways to draw or detail a building so that you can get it built properly. So the main ways are plans and elevations. We drew a little floor plan. We're going to draw another floor plan today. Elevations are looking at one face of a building. Sections are where you cut through a building, say at the midpoint, and pull part of it away so you can see what's happening on the inside. So they all relate to describe it in a three. They try to give a 3D form for the building. When we draw in AutoCAD, we're always drawing in 2 dimensions. When you take Revit, which is a 3D modeling program, you'll be drawing in 3 dimensions. It's a very powerful program. If you're in the AAS degree, it's in your 2nd year, so you've taken it fall next year if you follow the program. So let's get into what multi-view drawings are. The first one is a plan. So we talked about this last week. The plan is the top view of a building at each floor level, and it's cut through at 4 feet above the finished floor level at each floor. And it's like you took the whole top of the building off and you're looking down on it if you could be way up in the sky. And what would you see if you were looking straight down? So it's going to show the walls, columns, doors, windows, fixtures, countertops, kitchen cabinets. It won't show detail like trim. It's going to give you the big overall picture. And what you cut through is heavy, and what you're looking down on is lighter. What's above you is dashed. So I'll show you a couple of examples of floor plans. So here's a floor plan of a house. I'm trying to see it's all bedrooms back here. So this must be a 2nd floor plan because there's some kind of family room here, and I'm not seeing a kitchen. But you can see we've got some excavated basement area here. So this looks like a house that's cut into a hill. And here are bathrooms. So we see the toilet fixtures. Let me get my pointer. Here are bathrooms. So we see the toilet fixture. We see the toilet, the tub. We see the sinks. Notice doors are as shown in an open position. Here's a bedroom. Normally, unless it's you wouldn't see the furniture on the floor plan. You'd see dimensions and other things, and this would be a furniture plan. But this helps us to understand it, to see the furniture. So again, this is a coat closet. It's a dashed line with these little angled lines representing hangers. This is a fireplace over here in the family room area. So we've got 1, 2, 3, 4, 5 bedrooms here, and we've got 1, 2. Looks like 2 bathrooms and a little kind of kitchenette here. This is stairs. So when you cut through the stairs, so these stairs are going down, and these stairs here, this is a closet. So these stairs are going down, and the reason I know that they're going down is you'll see all of the stair as it's going down until you hit the floor of this, whatever this storage area is. When you're going up, you only see the stairs at up to a 4-foot point, and then you'll see a break line in there. Let's see, what else can I point out on here? These lines right here are section cut lines, and we'll see sections in a minute. So this is a section cut, and it's telling you I'm cutting this building all the way through right here, and the arrow's pointing in that direction, so that means I'm pulling this away and I'm looking at everything from this line up to the top. So the arrow tells you the direction you're looking at, and the line tells you where the section cut is done. Normally these section cut lines only go partway into the drawing on each side, so as not to make the drawing too busy. So that's a floor plan. Here's an elevation. An elevation is a view of one face of the building. So if the building is square, it's going to have 4 elevations. If it's an octagon, it's going to have 5 elevations. And it's as if you were looking straight onto the building. You have no perspective. It's not something that we see in reality in life, usually, or I see in perspective. you would only really see a true elevation of a building if you were really far away and you're seeing just the front facade. So it's a flat view. We use line weights to indicate depth. So what's farther away is lighter, what's closer is heavier, and that's how we indicate depth in elevation drawings. So it can be front, rear, side, whatever part you'd like. And then, so here's examples of elevations. This looks like it's, trying to see what kind of building this is. Might be like a retirement home or something. So you can see here's our front elevation with the stairs going up. Here's a side elevation. If you have any grading or contouring, that's going to show up on the elevation. And then there's notes, which are hard to read on this one. But you can see they have front elevation, entrance elevation, rear, back, and side elevation. Normally you designate them north, south, east, and west. Excuse me. We also have interior elevations. So this is an elevation of a kitchen. And kitchens and bathrooms are normally going to have interior elevations because they're pretty detailed, and it will also help you to lay out the cabinetry and figure out what cabinetry you're putting in here. So you can see from this is the base cabinets. Here's a window up above. These little dashed lines in here, usually they're a little bit bigger, more centered. They indicate glass. That means that's a window. Refrigerator, stove, wall oven, hood. And then you have dimensions all across. Usually when you're doing bathroom, kitchens, you'll dimension in inches as opposed to feet and inches, and that's because that's how the cabinets are purchased in inches. If you buy stock cabinets, they're in 3-inch increments. So that's an interior elevation. So a section, we already talked a little bit about it. It's a view of the building or object as if you cut through it. It shows different levels and how spaces are interconnected. It helps you to clarify plans, especially if you don't have a straightforward building. Like think of a split level house. A section would really help you to understand how the different pieces go together. If you have a building like we have the G building, a section's probably not going to show you a ton of information because it's a pretty straightforward building. So here's a section of a building, and this one tells us a lot. We've got floor plans here, but we've also got this little cutout courtyard area at the bottom, and you can see how the stairs go in and where they land for each side. And this one's also showing where someone's got views out. And here it shows how the sun's coming in. So you can use a section to show how the sun impacts your building, how views are used, and then again, how spaces are arranged so that you have a better understanding of how it's put together. So construction drawings typically contain the following drawings. They contain architectural drawings, MEP drawings, which are mechanical, electrical, plumbing, and structural drawings. And within the architectural drawings, you're going to have a plan of every single level of the building. Absolutely. You're going to have a roof plan and a basement or foundation plan. Sometimes the basement plan is finished off, so that would be a finished plan. Sometimes it's just a rough space, so you just see the foundation walls. You'll have a site plan that indicates where the building is on the site, and then you'll have elevations, sections, and you'll have specifications. And the order of this can change around a little bit. Often specifications and site plan come before the plan of the building. If I were doing, I would do specifications, site plan, basement plan, and then go into the plan of the building by starting with the lowest level. MEP drawings are the mechanical, electrical, and plumbing. On a bigger project, they're done by a mechanical engineer and electrical engineer. Mechanical engineer will do mechanical and plumbing, and the electrical engineer will do the electrical drawings. And then you'll have structural drawings. If you have a really big project, you'll even have civil drawings, which are how utilities come to the site, etc. So the structural drawings are done by a structural engineer, which you want to use almost all the time, because that's their job is to make sure it's built properly and will stand up well. So specifications are it's a written, detailed description of the work that's to be done on a project. There are it gives you instructions on what the object number is, what its title is, what the material construction is, how it's to be stored on site, how it's to be used, who you're purchasing it from. There's a whole lot of detailed information. The tighter your specifications are, meaning the better written they are, the more likely you are to get what you intended. If your specifications are kind of loosey-goosey, the contractor is going to cut corners wherever possible to save money, and you're not going to get as detailed or as fine of a project as you had hoped for. There are people who just are specifications writers. That's all they do. Excuse me. A bigger firm will have spec writers right in their firm. Smaller firms will use spec writers that are consultants that will come and write the specs for a particular project. So specifications are really important, and they tie back into the drawings. So you've got your drawings, you've got your specifications. Together, tell the builder what you want to have done. So there's a Construction Specifications Institute, CSI, and they came up with a master format for laying out all the specifications. And there are different divisions depending on what you're specifying. Before 2004, it had 16 divisions. Now it has expanded to 50 divisions. And that's because the building complexity buildings are getting more and more complex. 40, 50 years ago, you were not wiring buildings for internet. You were not having a lot of the technology that we have. More than that long ago, you were not having fire suppression systems. The lighting control was a lot different. So the buildings are much more complicated, and hopefully in a good way that protects us. There's also, it integrates with BIM. The master format will integrate with the BIM. That's the Building Information Modeling, which is Revit is the major player in that, and that's the class that we teach here. So that's the 3D modeling program, which can also give you material takeoffs, and there's a lot of things you can do with BIM. And then this is a standard used for commercial and institutional buildings in the US and Canada, not for residential. Residential specs are often just typed out on the sheets with the plans, etc. And part of the reason it's really important to be real strict in institutional and commercial buildings is you have to usually competitively bid them. And if it's a institutional building, you have to take the lowest qualified bid. So you want your specs to be really tight so that they're not substituting something that you don't want. And in a residential building, you have a lot more control because you can just say, this is the product I want, no substitution. You can't do that when you're bidding out an institutional building. So having a tight set of specs is really important. This is really hard to see. I'll put a print of this online. This is some of the specs. You really can't read it on here. I'm going to zoom in for myself, but you won't. If you want to zoom in, it has concrete masonry, openings. I'm going to print this out and put it on Blackboard because it's really hard to read from the computer. But you can also go to Wikipedia and they list all the 50 divisions. So here's what a spec looks like. A spec is as I said before, it's a written out set of criteria for the building. And first you do the scope. So the scope means, what am I going to do here? And you'll have a number up here, and that's the division number that you fit under. So in the scope, you'll say this work consists of da da da, and this one is a compost filler sock. And then you list the quality. So this is where you list what you want in it. If it's a wood item, you might list the quality of the wood, the type of the wood, if it's metal, you might list the thickness of the metal, etc. Then you're going to list storage. How are you going to store this on site so they just don't throw it out? They ordered it, you paid for it, and they throw it on the site and it gets all wet and ruined. or you don't know it's wet and you've got moisture trapped in your wall. So storage is really important. So they'll tell you how to store it, and then how to prepare the surface where this is going to be applied and how to place it. So this is a very short spec, some are pretty long. When you buy a particular product or specify a particular product from a manufacturer, they will provide you with a set of generic specs that totally meet their criteria for their product. And that spec is usually written so tight that there's not an easy alternative for it. And that's really what you want. Several years ago, a long time ago actually, I did the playground for my daughter's elementary school. I did the design. There were two major manufacturers of playground equipment, and I wanted one over the other. And the way I was bid out through the school because it went through the school district, and the way I was able to get the one manufacturer over the other that I wanted was I indicated a minimum deck dimension. So when you're on the playground and you climb up, you're on a deck before you go down the slide or climb across something else. So the manufacturer I wanted had a larger deck dimension. So I was able to specify that deck dimension and get the playground equipment I want because the other one couldn't meet that criteria. So that's one of the ways you can do it. Here's another sample. I'll put this whole PowerPoint up on Blackboard, but I'm also going to download some spec samples. So these are the basic components of a project. Again, it's plans, elevations, sections, and then specifications. So are there any questions on this? I have large sheets. If you're ever in here and want to look at them, I have big drawings of some historic buildings in Chicago and some specifications. I have at home, I have to bring in Unity Temple, did their restoration, I think it was 4 years ago now, and it finished. It was a $20 million restoration. My husband was on the advisory committee for the church, or the oversight committee, and so he had a set of documents. So I kept those and I'm going to bring them in. But I have lots of samples, which normally we would sit and look at. So I'll try to find some more from another class that I taught and pull those out for you to see. Any questions so far?
I think we're good.
Okay.